Assalamu alaikum. Welcome to today's chemistry class lesson. I'm Amnat Ziflin Ismail. I'm a leading teacher working in Kalafan School. Students, please scan the QR code given here. You can find the link above and please mark your attendance present. Today we'll be starting chemical bonding. Before we start chemical bonding, I would like to remind you about the topics that you have studied before. You should have studied about atomic structure, the subatomic particles, and also the electronic configuration, how to draw electronic structures, as well as periodic table. So this will be very easy for you if you just go through them before you read through it. Looking at the objectives, that means the points that you have to achieve at the end of the lesson. So the first objective is you should be able to describe the formation of ions by electron loss or electron gain. State and explain that metals form positively charged ions, which is known as cations, and non-metals form negatively charged ions known as anions, to obtain the electronic configuration of a noble gas. Deduce the charge on the ion formed based on the electronic configuration of the element. Draw dot and cross diagrams to show ionic bonding between metals and non-metals. So as we go along the topic chemical bonding, we will also be referring to what ionic bonding is and how to draw ionic bonding structures as well. So first, before we move on to ionic bonding, I would like to explain to you what an ion is. So first we need to know what an ion is, how an ion is formed. An ion is an electrically charged atom or a group of atoms formed by the loss or gain of electrons. So ion particles are formed when an element either lose or gain the electrons. You already know what an electron is, and also you already know the charge of an electron. This loss or gain of electrons takes place to gain a full outer shell of electrons. So the purpose of these particles to lose and gain electrons is to form a full outer shell, to gain a stable electronic configuration. The electronic structure of an ion will be the same as that of a noble gas such as helium, neon and argon. Now noble gases means the group 0 elements in the periodic table. As I said before, you should be very familiar with the periodic table also now. So looking at the periodic table, these elements, when they gain or lose, they obtain an electronic configuration as that of noble gases. I'll do one example on the flipboard so it is very clear for you what this means. Now for example, let's say group 1 elements like lithium, sodium, potassium. If we take sodium, the mass number of sodium is 23 while the atomic number of sodium is 11. To which number do we write the electronic configuration, students? Do you remember? That's right. We write the electronic configuration for the atomic number. Okay? So when we write the atomic electronic configuration for the atomic number, the first shell of sodium will contain how many electrons? 2 electrons, then 8, then 1. So that gives the total number as 11. That's 11 electrons. Now when this atom wants to obtain a full electronic configuration, what this atom does is it loses this electron. Then it becomes an ion with a positive charge, and now the electronic configuration will be 2, 8. I hope you are clear with it. Once again I will repeat. Sodium, the atomic number is 11. So the electronic configuration is 2, 8, 1. With 1 electron in the last shell, which we call as the valence electron, it is not stable. So to become stable, this electron is lost. It forms a positive ion with the electronic configuration 2, 8. This electron is no longer there. Okay? So that's how an ion is formed. Now here sodium is a metal, it belongs to group 1. So, now you know that all the metals in the periodic table, they will form positive ions because they are losing electrons. Referring to this point, the electronic structure of an ion will be the same as that of a noble gas. Now, if you calculate the total number of electrons of sodium ion, how much is it? Can you just take a few seconds to check? 8 plus 2 is 10, right? So, the noble gas which is having an atomic number of 10 is neon. Okay? So, this is representing the electronic configuration of the noble gas neon because it gives a total number of 10 electrons. Okay? Now, there are two types of ions. Now, we know how ions are formed and we already know that metals will form positive ions. So, let us look at what are the two types of ions that is formed. One is cations. Okay? So, what cations are? They are ions with a positive charge. So, Na plus is a cation because it has a positive charge, and as you all know, all the metals will lose electrons to form the positive charge. The second type of ion is anions. So, anions are ions with a negative charge. So, cations are the metals while anions are all the non-metals. Okay? So, non-metals will gain electrons and they form a negative ion. They are known as anions. So, the two types of ions are cations and anions. Now, here is an example just to make it more clear for you all. Now, as you can see here in this diagram, we are showing the electronic configuration structure for sodium. As you can see in the nucleus, 11 protons, 12 neutrons. So, in the shells also they will have 11 electrons. So, that means in the first shell 2 electrons, in the second shell 8 electrons and in the third shell 1 electron. This is actually empty spaces which I have highlighted using white color. Okay? The electron is in a different color. So, here we have the 1 electron which we call as the valence electron. Now, this electron is lost and then when we redraw the structure for sodium ion, this shell is not included because that 1 electron has already been lost, right. So, first shell 2 electrons, second shell 8 electrons, and inside the brackets you draw the structure, outside the bracket you write the plus sign. So, this is how you draw the electronic structure for an ion. We will see one more example. So, the second example is from a non-metal. The example we are taking here is for chlorine atom. Okay? So, chlorine belongs to which group? Students, do you all know to which group chlorine belongs to? Well, chlorine is a halide ion, it is a halogen. So, it belongs to group 7. Okay? So, chlorine atom, again first shell we have 2 electrons. Always the first shell, the maximum number of electrons it can hold onto is 2 electrons. Starting from the second shell, the maximum number we can add is 8 electrons. Okay? Then second shell we have 8 electrons, but in the third shell we have 7 electrons because chlorine is in group 7. Always the group number represents the number of electrons it will have in the outermost shell, which we call as the valence electron. Okay? So, now this is a non-metal. What does non-metals do to gain the stability? Yes, true, it gains the electrons. Okay? So, this chlorine atom will gain 1 electron to form the chloride ion. So, this is how you will be drawing the electronic structure for the chloride ion. Okay? Now, sometimes when we ask questions, we might ask you to draw the full structure even. Okay? And sometimes we even ask you to give only the outer shell electrons. If you are asked to draw only the outer shell electrons, you will not draw the first 2 shells. Only the last shell electrons you will be drawing. Okay? So, students, remember to read the question carefully and figure out the important points from the question before you write the answer. That is very, very important. Okay? So, here in the chloride ion, we draw the structure within the brackets and then the charge is minus. Minus represents that it is a anion, it is a negatively charged particle, and how many electrons it is gaining? It is gaining 1 electron. If it is more than 1, we can write the number here, but if it is just 1, you can ignore that number and then you can write the charge only. Okay?
Usual recommendation for a mask mean hama me normal surgical mask and me bali hunna mihun symptoms alametam hunna mihun ek masking alage moleshe eta then ane mege hore eki an area eki recommendation misala ka by befolong hunna wara close contact misal confirm case ekka bali miha kare hunna mihu vejia mijene wakiwatte gen 95 mask kya masking ala henone generally mihunge tere dar mi normal surgical mask mi recommendation kamin nane kam ke mask ke wese gotang me den ji balla fa gengola fe got kanone gengola ne remove kolla fe illa danje hene ema aich ke danje ne
Now, moving on to the types of bonding. As I said before, we will be learning about one type of bonding today under chemical bonding, but there are 3 types, different types of bonding. Okay? Among them are ionic bonding, covalent bonding and then metallic bonding. Okay? So, first we will start with ionic bonding. I will explain to you what ionic bonding is, how ionic bonds are formed and how to draw the structures. So, looking into the main points under ionic bonding, it is formed between metals and non-metals, involves the transfer of electrons, a very important term, the transfer of electrons between metals and non-metals. Ions are formed. Now, you know how ions are formed, right? Metals form a positive ion which is known as cations, while the non-metals form negative ions which are anions. Okay? The metal cation and the non-metal anion attract each other, forming a stable compound known as an ionic compound. Now, when there is 2 particles which are oppositely charged, you know from physics even there will be a force of attraction between them. Now, in chemistry we call this force of attraction between the ions as electrostatic force of attraction. Okay? So, the positive ion which is the cation and the negative ion anion will have a force of attraction, and that forms a compound which is known as an ionic compound. The ions are arranged in a regular giant lattice structure. So, when we move on, we will be learning in detail what this giant lattice structure is. We will first focus on what ionic bonding is. Some of the features of ionic bonding. Before we learn how to draw the structures, we should know what are the features of ionic bonding. So, some of the points which you have to remember: metals lose the electrons in the outermost shell to form a cation and gain a stable electronic configuration. So, all the metals, they lose electrons and they form or they gain a stable electronic configuration either with 2 electrons or with a full outer shell of 8 electrons. The positive charge on the metal ion is equal to the number of electrons lost. Now, if you refer to the example we did on the flip chart, sodium ion, can you see the charge? It is Na plus, which means that sodium has lost 1 electron. So, this point is very much highlighted in that example. The positive charge on the metal ion is equal to the number of electrons which is lost. So, for example, here it is given potassium. Again, potassium is in group 1 of the periodic table. It will lose 1 electron and become a potassium ion with the formula K+. Looking at non-metal ion features, so non-metals gain electron to form anions which we call as negative ions, and the purpose is to gain a stable electronic configuration. The negative charge on a non-metal ion is equal to the number of electrons gained. Now, I will do one more example on a non-metal. So, let us take an element which you are familiar with, like chlorine. Okay? Chlorine atomic number is 17, mass number is 35.5. Okay? If you write the electronic configuration for chlorine, what will be the electronic configuration, students? Let us write down. Okay? First shell will have 2 electrons, second shell will have, maximum will be 8, 8 plus 2 is 10. How many electrons are remaining from the atomic number? 7 electrons, right? So, that 7 electrons will go to the third shell. Now, this is a chlorine atom. Now, to gain the stable electronic configuration, with 7 electrons it is not stable. It needs how many electrons to become stable? Yes, it needs 8 electrons. So, this chlorine atom will gain 1 electron to form a negative ion Cl minus. Okay? So, the electronic configuration of this ion will be 2, 8, 8. Okay? So, that is what means here. Okay? Here in this point the example given is oxygen. Oxygen has 6 electrons in its outermost shell. So, oxygen needs 2 electrons, that is why the charge of oxide ion is O2 minus ions. Hope it is clear up to here. We will continue with the diagrams now. Okay? Okay. Now, in this slide you can see that there are 2 structures, electronic structures. One structure shows sodium ion, the other structure shows the chloride ion. Okay? Now, the statement says ionic bond results from the electrostatic force of attraction between the oppositely charged ions. 2 very important terms, electrostatic force of attraction between the oppositely charged ions. What are the oppositely charged ions present in the structure? We have a positive ion and we have a negative ion. So, this force of attraction binds the molecule together and it forms the ionic compound. Okay? Now, we are going to learn how to draw the structures. So, it is important that you have a paper and a pencil with you so that you can draw along with me as well. Okay? So, the first example is sodium and chlorine to form sodium chloride. Now, first I have shown you the symbol of sodium and chlorine which is given in the periodic table. Okay? So, sodium atomic number is 11 while chlorine the atomic number is 17. Can you all please take some time to write down the electronic configuration of these 2 atoms? I will give you some time for you to write down the electronics configuration. Ready? Okay, hope all of you have written the electronic configuration. Now, this is the electronic configuration. Okay? Sodium atom 281. Have you already written this one? So, 281, 2 plus 8 plus 1 will give 11. So, that will be the electronic configuration of sodium atom. Okay? And then we have chlorine atom where the electronic configuration is 287, atomic number is 17. Okay? Then I have drawn here the electronic structure, the full electronic structure of both the atoms. Okay? Now, you can see there is an arrow which I have placed from one atom to the other. Now, in the explanation I told you that ionic bonding involves the transfer of electrons from the metal to the non-metal. So, the metal loses its electrons to the metal, to the non-metal to gain the stable electronic configuration. Okay? So, now after losing and after gaining the electrons, how will the structure look like? Why don't you give a try and draw the structures to compare with mine? I will give you some time to do that. Done? Yeah, let us see. So, here are the structures. Okay? So, sodium ion Where is the third shell? The third shell is not there anymore. That electron has been lost, and that electron is gained by the chloride ion. Okay? So, that is why there is a red dot here in the chloride ion. Okay? Remember, you draw the structures inside the brackets, and then you write the charge outside the bracket on top corner side. Okay? You should be very thorough with this when you are drawing the structures, and these structures should be very neat and clear. Okay? So, here is the electronic configuration for sodium ion and for the chloride ion. Okay? One more example. Magnesium and oxygen to form magnesium oxide. You know how to write the electronic configuration now. We will just go ahead with the electronic structures. Okay? So, you have magnesium, oxygen. So, as you know, magnesium is in group 2, which means magnesium being a metal will lose the 2 electrons to gain the stability. Okay? So, loses 2 outer electrons, and what happens when it loses 2 outer electrons? It forms a positive ion. What do we call the positive ion? It is a cation. Okay? Oxygen, which is in group 6. So, how many electrons does it need to become stable? It needs 2 electrons, right? So, gains 2 electrons and forms a negative charge ion, which is an anion. Okay? So, here is the structure. Magnesium with 8 electrons, it has lost 2 electrons, that is why there is a charge of 2 plus, and then we have oxide ion, oxygen ion, O2 minus, it has gained the 2 electrons. Okay? One more example, I will just show you the diagram here. Now, we have done 2 examples. So, hoping that you are familiar with to draw the structures. I will just show you the structure for ionic bonding for calcium oxide. So, calcium we have Ca 2 plus 8 electrons in the last shell, oxide ion 2 8 O2 minus. Now, this diagram is not showing all the electrons, it is showing only the outer shell. Okay? Previous diagram I showed you all the electrons. There is also one way we can draw the structures, but most of the time in past paper questions they will ask you to draw dot and cross diagrams. These diagrams are known as dot and cross diagrams because we are using dots and crosses to represent the electrons. Okay? So, dot and cross diagrams to show only the outer shell electrons. Okay? So, just to sum up, keeping in mind what you have studied today and also the objectives of today's lesson, a chemical bond is the physical process that causes atoms and molecules to be attracted to each other and held together in more stable chemical compounds. So, a chemical bond is atoms and molecules that are attracted together to form stable chemical compounds. When atoms bond, electrons are either shared or exchanged. So, when atoms bond together, the atoms can share the electrons, they can exchange the electrons or transfer the electrons. Okay? In ionic bonding, what happens? In ionic bonding, the electrons are being transferred from the metal to the non-metal, and then positive ion and negative ions are formed. Okay? So, an ionic bond involves transfer of electrons from the outer shell of a metal to the outer shell of a non-metal. So, in ionic bond we always have to remember that it takes place between metals and non-metals. So, now it is your time to evaluate yourself. I have a task for you. Okay? Now, you all should have the chemistry workbook with you. Okay? This is the chemistry workbook. So, I want you to turn to page number 34 and 35, exercise 3.5. You can do these questions and then you can forward your answers to your teachers. They will provide you feedback. Okay? Make sure to clarify your doubts even if you have a question. You can even watch the video again or you can even ask your teachers. Okay? But keep in mind to do the exercise and get the feedback from your teachers. So, that is all for today, but before that make sure you mark your attendance as well. Scan the QR code, log into this link and then mark present. Okay, have a good day, stay safe and stay home. Thank you.